All right, we're going to get right into today's lesson here. And so we're going to jump right into the document that you guys should all have. And I'm going to start to read off the definitions here. The good thing about it being recorded is if I go too quickly, you can always go back and re-listen to something. So for an inscribed angle, I want you to write this down. An angle that has a vertex on a circle and sides that contain chords of the circle. Okay. So again, an angle that has a vertex on the circle, that's the important part, and sides that contain chords of the circle. So what does an inscribed angle look like? Well, let's start with what we talked about last week. Well, no, let's not do that. Let's just do inscribed. So a chord looks like this, okay? And so the inscribed angle has this vertex right here. I'm going to label it, let's do A, B, C, okay? And maybe you can write down that angle BABC equals inscribed angle. Okay, inscribed angle. Now, for the definition for an intersected arc, let's see here. An intersected arc has endpoints on the sides of an inscribed angle and lies in the interior of the inscribed angle. Okay, so I would just put this down, an arc that lies on the interior of the inscribed angle. Okay, an arc that lies on the interior of the inscribed angle. So if you look here, we've got this inscribed angle on the interior. The only arc that's on the interior, that is arc AC. Okay, so I would say something like this: angle ABC intercepts arc AC. Okay, that's the arc that is intercepted by that inscribed angle. Okay, now this next part is pretty cool, where I'm going to go ahead and label a couple of inscribed angles. Okay, so we've got A, B, and C. Okay, so let's start out with something basic here. I could go ahead and say something like this: that angle A plus angle B plus angle C equals 180 degrees, right? Because it's a triangle. Now, just keep that in mind. If I were to ask you guys, if I were to add up arc AB and arc BC and arc AC, what would that equal? So if I went from here to here, here to here, here to here, what would that equal? Well, that would equal 360 degrees, okay? Now, if I were to tell you that the inscribed angles have a relationship with the intercepted arcs, what do you notice right now? And if you're thinking to yourself that the inscribed angles are half of the intercepted arcs, which is why their sum is half as much, you're exactly right. So I can go ahead and say something like this: this angle A intercepts this arc down here, okay? So maybe I'll do this: angle BAC is actually half the measure of its intercepted arc, which is going to be BC, okay, because it intercepts that arc. If I do the angle at C, so angle ACB, that's half of the intercepted arc over here, which would be AB, okay? And the last angle over here at B, so angle ABC, is going to be half of its intercept arc. So again, this is the angle. Where does the intercept? It'd be this arc right here, right? Okay, so if you need to, draw it all the way out, and right there. Yeah, it's in between. So it's arc AC. Okay, so we've got that relationship there. Okay, so I want to take you back and review something here real quick, and that's this. If you remember back to last week, if that's the center point of the circle, okay, I'm going to do it right here. Let's say that this angle is 60 degrees, okay? So this arc out here has to be the same amount because the central angle is equal to the arc measure, so 60 degrees. And then what we're going to do, I'm going to go over here and inscribe the angle. And this angle right here is going to be half as much. So it's going to be 30 degrees. Okay? So, what's the inscribed angle theorem? Well, go and write this down. It says this. If an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. Okay? So the measure of that inscribed angle will measure 1/2 the measure of its intercepted arc.